In this video, we're now going to go through the second type of a non-homogeneous second order differential equation. So in our case, our function is equal to 2x. So please pay attention that we've derived the complementary function from the previous video where we said that y is equal to a times e to the 3x plus b times e to the 2x. So you can always go back and watch that again if you need to figure out how this was derived. So our particular integral, according to the table, is k times x, so it'll be y is cx plus d. So we differentiate this, so we get dy by dx equals c, d2y by dx squared is 0. Substituting this into our equation, we get 0 minus 5c plus 6 times whatever our y function was. Our particular integral is cx plus d equals to 2x. So that's now going to give me minus 5c plus 6cx plus 6d is equal to 2x. Now we're going to equate the coefficients of x, so equating the coefficients of x. So we get 6c is equal to 2, c is equal to 2 over 6, that's a third, and now we're going to equate the constant terms. So equating the constant terms, so because there's no constant term, it's going to be minus 5c plus 6d equals 0. So let's write that down. So minus 5c plus 6d equals 0. And we can substitute the value of c in. It's minus 5 times a third plus 6d equals 0. Minus 5 thirds plus 6d equals 0. 6d equals 5 thirds. D is 5 over 18. So our particular integral is y equals cx plus d. So in our case, third x plus 5 over 18. So in general, the general solution is y equals cf plus pi. So in our case, it's going to be the following: a times e to the 3x plus b times e to the 2x. I'm going to write the particular integral in pink here. So plus a third x plus 5 over 18 is our general solution. Here's a question for you to try. You can pause the video. When you're done, I will go through my work solution. Okay, welcome back. So we need to work out the complementary function. So let's write down the auxiliary equation. M squared minus 8m plus 12 equals 0. So m minus 6 and minus 2 equals 0. So our roots are m equals 6 or m equals 2. Our CF is y equals e to the power 6 times a plus b times e to the power 2x. So now it's a form of k times x. So we write the particular integral. Just as before, y equals cx plus d dy by dx is c d2y by dx squared is equal to 0. So now substituting this into our equation, we get 0 minus 8 times dy by dx, which is c, plus 12 times y, which is our particular integral, cx plus d. Now that's equal to 36x. So we can say minus 8c plus 12cx plus 12d is equal to 36x. So now equating the coefficients of x, that gives me 12c equals 36, c equals 3. Now we're going to equate the constant terms. So equating the constant terms, so we're going to get minus 8 times c plus 12d. There isn't a constant term, so we get 0. So minus 8 times 3 plus 12d equals to 0. Minus 24 plus 12d, 0, 12d plus 24, d equals 2. So we can say that our particular integral is in the form y equals cx plus d. So we can say y equals to 3x plus 2. That's our particular integral. Don't forget our general solution is always in the form y equals to cf plus pi. Now, be careful, our cf was that a times e to the power 6x. Let's write that down. Y equals a times e to the power 6x plus b e to the power of 2x plus the particular integral, which is in pink here, 3x plus 2, and that is our general solution.